Hi everybody, welcome to Unit 10 already. We are looking at trigonometry today, introduction. Trig is the study of the relationships between the sides and the angles of triangles. You may be familiar, if you can see where I'm highlighting on my screen here. These three buttons on your calculator look like sin, cos, and tan, but they are sine, cosine, and tangent. That's how we should say them if you're talking about them. The full words look like this, S-I-N-E for sine, but we'll usually write S-I-N. Cosine and tangent. Those are the three trig functions we're going to learn about today. Some other terminology you need to know. We're going to use this Greek letter, theta. It is used to represent angle measures. So when you see that symbol, theta, you can assume that they're talking about an angle. Okay, so we're going to start by drawing a right triangle. By the way, this only works for right triangles. We're talking about with sine, cosine, and tangent. So I'm going to put a right angle in there. And then I'm going to pick one of my other angles to be theta. It could be either one. I'm just going to pick this one for now. And based on the location of that angle, I'm going to label the rest of my sides of my triangle. All the way across from theta is what we would call the opposite side. Next to theta, we call the adjacent side. Now, if you're, imagine that you're standing in this angle here. We have a little stick figure, we're standing in this angle. There are actually two sides next to you. There's this side here and this side here. But the one that's across from the right angle, we always call the hypotenuse. In every single scenario, that's the hypotenuse. So then by process of elimination, this is our adjacent side. Now, that all depends on where theta is located. So if I were to move my little stick figure guy over here, now my opposite side and my adjacent side would switch places. Okay, we're not going to do that right now. You can leave your notes as is. Sorry if you started erasing there already. But that, again, is all based on the location of which angle you're choosing. Now, here's how we define sine, cosine, and tangent. They are just a ratio, think fraction, of the different sides of the triangle. So if I talk about, and it's always sine, cosine, or tangent of an angle. So if I'm talking about sine of theta, look how I'm writing this, sine with a little theta right after it. Now, that is not multiplication. Okay, and in your calculator, it will likely pull up a parentheses. That's not multiplication. We're plugging theta into the sine function. You don't have to understand what that means yet. Okay, so sine of theta is just this ratio. It's the ratio of two sides. You take the length of the opposite side, and you divide it by the length of the hypotenuse. Whatever number you get, that is sine of the angle. Cosine of theta is just a different ratio. It is the ratio of the adjacent side to the hypotenuse. It's just some number. Talk about those numbers later. And then tangent of theta is this ratio, opposite over adjacent. So that is how sine, cosine, and tangent are defined. They are just a ratio of two of the sides of the triangle. The sides that you're using and the order in which they show up depends on which trig function you've picked, sine, cosine, or tangent. Now, to help us remember that, because it is worth your time just memorizing how these look, how they are defined, we have this little shortcut that we use, this little tool that we use. We're going to pull some of the letters off and write out this little phrase that maybe you've heard before. So from the first equation here, I'm going to take the S from sine, the O from opposite, and the H from hypotenuse. And what I have is S, O, H. I'm going to write it out like that. Same thing with cosine. Take the C and then the first letter from each of those ratios. So I'm looking at CAH right after that. I'm going to make this all one big word. And then from tangent, take the T, the O, and the A. You may have heard before in a math class, SOHCAHTOA, or maybe heard some of your upperclassmen friends saying that phrase. That is a little tool we use to help us remember the trig ratios. So if we go through this, sine is opposite over hypotenuse in that order. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so if you can remember SOHCAHTOA and you need to spell it correctly, here's where I see a mistake. Make sure you make that an A, SOHCAHTOA, not SOHCAHTOA. That will help you remember what the ratios look like for each trig function. Okay, so let's try an example and we'll see how this works exactly. And there's a couple different scenarios we're going to come across today. Okay, so our first example here, let's just say we have maybe a 3, 4, 5 right triangle. That's one of those Pythagorean triples. So just sketch with me a right triangle. I'm going to label the sides 3, 4, and 5. And then I'm going to label the angles. I'm going to use letters now, A, B, and C, capital letters on each vertex. So you might see sine of theta, or they might have a different name for the angle. So I'm going to ask for sine of capital A, angle A. It's always sine of an angle. I'm never going to put a side length here. We'll learn about a way to do that, but that's in the next lesson. Okay, so if you're asked for sine of angle A, well, let's put your little stick figure here. Imagine you're standing in angle A. Based on where you're standing, and let me write down SOHCAHTOA here so we have it. Feel free to write that all over your papers when you're doing practice problems. So sine is, I'm looking right here, opposite over hypotenuse. So that looks like, with respect to where our little stick figure is standing, the opposite side all the way across the triangle is 4. The hypotenuse, it doesn't matter where we're standing, the hypotenuse is the hypotenuse. That is always 5 in this case. So sine of angle A equals 4/5, period. Done. That's the answer. Okay, it's just a ratio of those sides. Okay, so 0.8. If you were to do something in your calculator, you'd likely see a decimal. We just say that's 0.8. That's it. That's the answer for that question. Cosine of A. Still standing in angle A. Now, be careful with the adjacent side. It's tempting to call this the adjacent side or this the adjacent side, but it has a better name. That's the hypotenuse. So our adjacent side is here, standing next to the little stick figure. So that's 3 over the hypotenuse, which is 5. 3/5, 0.6, done. That's the answer. Okay, and then the last one, tangent of angle A is opposite over adjacent. So remember, the little stick figure standing in angle A. Your opposite side is 4, your adjacent side is 3. Okay, so you might see a problem like that. Here are the side lengths, give me the ratios. Now, if we change the angle that we're talking about, we need to kind of notice what happens here. So now let's look at sine of angle C. So now my little stick figure's down here. Okay, so we're going to focus on this red one. The opposite over hypotenuse, I'm looking at SOHCAHTOA again, so opposite over hypotenuse looks like 3 over 5. Notice that's different than sine of A. I had 4 over 5 before, now I have 3 over 5. Cosine of angle C is adjacent, 4 over the hypotenuse, 5. Notice these just flip-flopped. Okay, so compare this one to this one. As I move to my different angle, right, I move from angle A to angle C, what was my opposite side, 4, now becomes my adjacent side. So there are some relationships that we can see happening in there. Okay, and then the last one here, let's just complete this. Tangent of angle C, stick figure standing in angle C, the opposite over adjacent is 3 over 4. You can see that's the reciprocal of this one, because the opposite and adjacent side just flip. As you move to another angle, they switch sides. Okay, so that's kind of example number 1. You could see something like that. Example number 2, you might actually have an angle measure to work with. Okay, so let's go to example 2. And the first thing I just want to look at is, right in the calculator, we're going to find sine of 30 degrees. Okay, so I'd like you to try to plug that in. Oh, I lost my sine. Sine should be right here. S-I-N. Lost my button there. But just go ahead and plug in sine of 30. Now, you should be getting 0.5. Now, if you're looking at your calculator saying, that is not what I have, maybe you have this, negative 0.988. We just have to make an adjustment on our mode in our calculator, okay? This is super duper duper important. It would be really unfortunate if your calculator was in the wrong setting and you missed every trig problem because of that. So I need you to find the mode button. Now mine's here. You can see if yours is in the equivalent spot on your calculator. Even on your phone calculator, you can change this mode. And what we want is degrees. The default setting, unfortunately, is radians. You see that word next to it? We don't want radians. It might say RAD in your calculator. We want DEG, or degrees. Radians is something you'll learn about in pre-calculus. Okay, it's a different way to measure angles that we have not discussed yet. So you have to make sure you're in degree mode. Now go ahead and enter in sine of 30, and we're hopefully getting 0.5. Now, let's talk about what that means. Trig is really hard initially to kind of grasp, like, what is this actually doing for us? What does all of this mean? So this is, notice I didn't have a particular triangle. Every single 30-degree angle in a right triangle will have a ratio, remember this was opposite over hypotenuse, of 0.5. That's 1/2, right? 1 to 2. So let's look at an example of that. Now, think about a 30-degree angle. We've got a 30, 60, 90 triangle. We'll use kind of just our base angle first. Let's fill in our sides of 1, 2, and the square root of 3. If I took sine of 30 degrees now, so you imagine you're your little stick guy standing in a 30-degree angle, my opposite over my hypotenuse is 1 over 2. But there are infinitely many sized triangles that have a 30-degree angle, right? Imagine we just copied and pasted and made this larger. So I'm going to make this, it's not going to be perfectly to scale here, but let's make it twice as big. So now I've got this 30, 60, 90. And my side, let's say it's even 3 times bigger, right? So now I have this short side of 3. My hypotenuse is 6. And the longer leg is 3 times the square root of 3. And let's take that ratio now. So sine of 30 degrees, here's your little stick figure standing in the 30-degree angle. Opposite from us is 3. The hypotenuse is 6. That still reduces to 1/2, or, like you saw in the calculator, 0.5. Okay, so in every 30-degree, or in every triangle with a 30-degree angle, the opposite over hypotenuse will reduce to 1/2. So sine of 30 is 1/2. Okay, sine of 30 is just asking you, okay, look at my triangle, tell me about my opposite over my hypotenuse. What does that number look like? What is that ratio? Okay, that is a little bit difficult to grasp. Feel free to rewind and listen to that one more time. Now, some other problems that you'll see. Let's look at an example here. If you need to take a second and write this down, go ahead and pause. Okay, so a distance of 36 meters from a tree. So here's, let me draw a little triangle here. Okay, so I don't know if you can read that. That says 36 meters. So 36 meters from the tree, an angle from the ground to the top of the tree, that's this right here, is 31 degrees. Find the height of the tree. Okay, it is safe to assume that trees, buildings, light poles, flags, all of those things that we've seen in triangle problems, they are perpendicular to the ground. So it's okay to put a right triangle in there. Okay, and then we are going to put our little stick figure guy here, and let's kind of label what we're working with. So this 36 meter side compared to this 31-degree angle, that's the adjacent side. And then the one that we're looking for, the height of the tree, let's just call that H. That, again, with respect to the angle, that's the opposite side. So what we need to figure out is which trig function do we want. So I'm going to write SOHCAHTOA down again. Okay, and we're thinking of this as, oops, three separate pieces here. We've got SOHCAHTOA. And the information that either we have or we're looking for, we've got opposite and adjacent. So you're going to look at SOHCAHTOA and say, okay, which of these has the O and the A? It's this one here. So we're going to be using tangent. Okay, so step one, label the triangle. Step two, choose your trig function. Okay, so now that we've chosen tangent, we're just going to write that equation down. This is the definition of tangent. It's opposite over adjacent. And let's plug in what we have here. Now, in this case, we have the angle. So we're going to take out theta and replace that with 31 degrees. The opposite side, we don't know. We're just going to call that H. And the adjacent side we have is 36. Now, remember, tangent of 31 is just some number in your calculator. Let me plug that in, make sure I'm in the right mode here. Okay, so tangent of 31 is about 0.6. We are not going to write that down. We're going to try to avoid some rounding error. But when you're sort of working through algebraically how to solve for H, just remember that this is about 0.6. So we want to get H. Let's just get rid of the 36. We're going to multiply both sides by 36. So H is equal to 36 times the tangent of 31 degrees. We'll just put that right in the calculator. It's approximately 21.63 meters. Just a note about your calculator. When you hit tangent, right away a parentheses pops up. This is for all the trig functions. So if you're going to put tangent of 31 in, and especially if you're going to maybe put it in this order, put that before the 36, please make sure right here you close these parentheses. We don't want to also put 36 into the tangent function. So as soon as you hit the angle, just get in the habit of closing your parentheses right away. Okay, let's try another one. Find the length of the hypotenuse of a right triangle if an acute angle measures 20 degrees and the leg opposite the angle measures 410 feet. So let's make a little sketch here. Just a small little 20-degree angle. Right triangle, this only works for right triangles. By the way, I don't think I mentioned this before. I do think it's helpful to draw those little stick figures, but you're never going to put the stick figure here. Okay, so think about, here's the issue right off the bat. If I'm going to label this side, it's the opposite side, but it's also the hypotenuse, right? Which one is this? And then this would be the adjacent, or this would be the adjacent. None of that works out. So when you're doing your little stick figure, guys, please do not stand in the right angle. Okay, but we do have a 20-degree angle. The leg opposite that is 410 feet. Find the length of the hypotenuse. We'll just call that X. Now, I would not suggest putting anything on this side, because if you do, it makes choosing your trig function a little more difficult. So we are just going to label two of the sides, the one we have and the one we're looking for. So across from the 20, this is our opposite side. The X, that's the hypotenuse. So if you think about SOHCAHTOA, the one with the O and the H is sine. So we're going to use the sine function. So just write down what it says. Sine of theta is equal to opposite over hypotenuse. And let's plug in what we have. We have the angle, it's 20 degrees. An angle always goes in there. Please don't put a side there. That is equal to 410 over X. Now, this one, just a little note here, is a little bit harder to solve for X. We are not multiplying by 410. If you did this, these don't cancel out. They're both technically in a numerator, so you'd actually be multiplying them and they'd be getting bigger. X is still not by itself. So what we need to do in every scenario is just multiply by whatever's in the denominator. So we're actually going to multiply by X first. Now, unfortunately, that does not get X all by itself yet, but it does get it out of the denominator. So now we're here, And then we just take one more step and we're going to divide by sine of 20. Now remember, that's just a number in the calculator. It's about 0.34. We don't really care about that right now, but you can sort of think about that as a number, so you treat it appropriately in your algebraic work here. So x is equal to 410 divided by sine of 20. That can go right in the calculator. X is about 1,198.8 feet. Okay, I'm going to give you a couple of practice problems to try on your own. Just a few here. Copy this down. If you are able to pull up the book, great. That's page 644. That is actually in Unit 12 in the book, or Chapter 12. So if you're pulling up the online book and you're going chapter by chapter, look for Chapter 12. Okay, that would be 12.1. But go ahead and try these. I'll scroll down in case you don't have the book available. You can copy these down. So pause and copy them down as you need to. Okay, so 1 through 6 is there. And then 14 through 16. Try them first, come back, we'll check our answers. Okay, here's the answers for 1 through 6. If all of those are wrong, first thing you check is the mode in your calculator. Be careful with this one, number 5. Remember, you are multiplying by x first, then dividing by cosine of 52. So this is actually what goes in the calculator. Okay, be careful with that one. Okay, and then the last group, check your answers. Let me make a little note here, just which trig function you should have used. So 14 is tangent, 15 is sine, 16 is cosine. Okay, as always, if you have questions, shoot me an email. We'll do some practice tomorrow. If you want to do a live session, we can do that. Have a great day.